So like Jeff said, my name is Janie Dussel. I do think I know a lot of the participants here. I'm the president of AWR Engineering, and we've been working with the municipality for many years on different green infrastructure programs. First, on developing the current municipal criteria for green infrastructure, and then more recently on implementing it. So the purpose of today's training, like Jeff said, is to talk about some barriers that we're seeing throughout the community on actually getting green infrastructure facilities implemented. We want to talk about some of those barriers and how to overcome them. This is not going to be every barrier. It's not going to be, all inclusive, but we're going to touch on the ones that we see the most commonly, the recurring themes, and hopefully give you guys some good tools and ideas and concepts to how to overcome those so that we can get green infrastructure implemented a little more seamlessly. So I want to do a really quick review. We've already heard from some other speakers today about this topic, but just a quick review on what is green infrastructure. So the definition on the screen from the US EPA is the same one that Ron talked about earlier. I'm not going to read it to you again because it's kind of long, but essentially the takeaway from this definition is to keep in mind that it is a range of measures, right? It's not one thing, it's a whole range of measures. A simpler definition that I like to use just because I think it's easier and a little bit more readily available to get your hands around or your mind around is it's just stormwater measures that use natural processes to clean runoff, basically. And by natural processes, I mean basically plants and soil. So what does green infrastructure do? It slows runoff down, allows it to filter through some soil or plant media, and remove sediment and attach pollutants. So as you look at this definition of what green infrastructure is, I also want you to notice what it's not. So I put this at the bottom of the screen here. Green infrastructure is not a synonymous term with infiltration. Infiltration is one tool that you can use to achieve green infrastructure, but it's really important to remember that these terms are not synonymous. You're going to hear me say that probably about 20 times in this presentation because it is really important. So I just thought I'd start by pointing it out early. So why do we need green infrastructure? Why do we do this? Why does it matter? There's two reasons. So one is practically, it's to clean our stormwater, right? So as stormwater runs across impervious surfaces, it picks up lots of different pollutants. We saw the way the municipality is testing for those pollutants with the presentation that HDR gave earlier, and they talked about, a range of those, but essentially most of the pollutants in our stormwater binds to sediment. And so if we can remove the sediment from our runoff, we're also removing our pollutants. That's the concept. So from a regulatory standpoint, the other reason we do it is because it's mandated. In our MS4 permit, it tells us specifically that we have to use green infrastructure treatment for stormwater, and the current municipal design criteria echoes basically what is in the current MS4 permit. So those are the reasons we do it. So another way that I like to present green infrastructure, just conceptually, just to kind of keep in your mind as you're going through today's presentation and working on projects of your own. The picture on the left is just water flowing into a traditional curb inlet, and the picture on the right is the outflow from the subdrain at the Taku Lake Rain Garden here in Anchorage. So if you think about this conceptually, just which one seems cleaner? If you were going to imagine putting your hands in this water or having your kids splash around in it or going wading or anything like that, which of these two pictures, like which water seems cleaner? When you think of it that way, most people will choose the water on the right because there's just something very intuitive about the fact that water flowing through nature is just cleaner, right? And it's intuitive because it's true. It is. Nature does a really great job of cleaning up stormwater when we give it the opportunity to do so. So just something to keep in mind. So there are so many different types of green infrastructure facilities, right? We couldn't talk about them all today, even if we wanted to. It would take hours. There are dozens, if not hundreds, of different types of green infrastructure facilities that exist. However, most of them rely on only a few processes to actually treat stormwater. So those processes are configured lots of different ways, but they're all just one of a handful of processes. And they're pretty easy to understand. So I'm going to talk about 3 of them briefly. These are not the only processes that can be used in green infrastructure facilities, but they are the most common, and they are, in my opinion, the most useful for facilities, at least here in Anchorage. I think they're the most helpful. So when I talk about infiltration, I'm talking about percolation of stormwater into the subgrade, into the existing subgrade. When I talk about filtration, it can be either through vegetation or through soil. So in this picture that we have shown here, this is a pretty standard, pretty common bioretention cross-section. And the primary treatment mechanism here is filtration, right? Water is going to come into this facility either through a curb opening or some type of sheet flow. And it's going to filter through the soil media. It's going to be, in this case, collected at the bottom in a subdrain pipe that then probably flows to a storm drain. It could flow to an open channel. It could flow to a creek. I'm going to actually go back really quickly. In the case, of this picture, that's exactly what this is. This is an outflow from a bioretention area that flows in this little swale directly to Taku Lake. But in a lot of cases, it just flows to directly connected to a storm drain. So the primary treatment mechanism here is filtration. You will also have a little bit of evapotranspiration in this facility. So evapotranspiration is just plant uptake. It just, these plants have roots that extend down into the soil, and they're going to use the water for their own biological processes. So those are the processes that most of the green infrastructure facilities you see are going to be using one of these 3 processes. There are, like I said, a few others, but these are the main ones. So I want to just briefly review the municipal requirement for green infrastructure. So it's presented in the DCM in the Design Criteria Manual, Chapter 2, Section 3.3.2.1. And basically what it says is we're required to use green infrastructure to treat runoff generated from the first 0.52 inches of rain in a 24-hour period. And that section of the DCM talks in a lot of detail about what that means and how to compute. Well, it's a different section, but it talks about how to compute that volume of runoff. And then it talks about the 20% area allowance. Christy also mentioned this earlier today. It talks about roadways with narrow rights of way, and then how to make an infeasibility determination. So because this is all pretty documented there, this is not the focus of today's training. I'm going to assume that this audience is already familiar with these sections. If you're not and you have a question, feel free to ask it at the end in the chat or verbally at the end of this presentation. We'd be happy to talk about it. So as I tell you the requirements, once again, notice what is not listed here as a requirement. Infiltration. Not required, right? Treatment is required, and infiltration is one tool you can use to achieve treatment, but it's not a specific requirement, okay? So just something to keep in mind. So we know that Anchorage has a lot of challenging sites. There's a lot of development happening where infiltration into the subgrade is not feasible for a whole host of reasons. Maybe you have high groundwater on your site. Maybe you have a lot of adjacent foundations next to the site. Maybe the right-of-way is narrow and there's not an opportunity to do that. That's not going to impact a roadway structural section. There's lots of reasons why, in some cases, infiltration is not feasible. Also, there's a lot of conflicting demands for limited surface space, right? Like every project, there's a whole lot of different requirements that are demanding that space, and this can be a big challenge for getting green infrastructure implemented. So we are aware of that. We know that these challenges exist. So what do you do? How do we handle this? So we're going to talk about barriers, some of the barriers to overcoming challenging situations. So barrier number 1, once again, is an infiltration or nothing mentality. So we hear from a lot of designers, from a lot of project teams, that if your site can't infiltrate into the subgrade, then we just can't do green infrastructure at all. It's not possible, can't make it work. So this is not true. So overcoming that barrier is first recognizing that infiltration is not a requirement, right? You've heard me say this now several times. It's not a requirement, but it's important to keep in mind because I think this is a common misconception. I think there are a lot of people out there that really do think they have to infiltrate water into the subgrade. That's not the case, right? There are other tools available to achieve green infrastructure treatment, which is a requirement, right? We have to do green infrastructure treatment. That is a requirement. So the tool that will most often work when infiltration won't is filtration. Filtration is very flexible and in a lot of situations will work when infiltration does not. So I'm going to show you a couple of just examples of how much I mean that you don't have to do infiltration. So this is what's called a stormwater planter. I do not see a lot of these in Anchorage, but they are commonly used in other places. This should look really familiar because this cross section that you're looking at here for stormwater planter is pretty much the exact same cross section here, right? It's just a bioretention setup. The difference is with the stormwater planter, we're able to put them in smaller spaces because you can go vertical with the sides. You don't need a stable side slope to hold itself at a 3:1 or whatever. The swale configuration usually takes up more space. But the primary takeaway here is these are used commonly as green infrastructure and they have a concrete bottom, right? So there's no infiltration happening here, not even a small amount. Everything is just filtering through this soil media, collecting in the bottom in a pipe, cleaner, and then discharging out, usually to a storm drain, usually a direct connection to a manhole. So yeah, these are photos. These are both out-of-state photos of stormwater planters. But the takeaway again is this is a great green infrastructure application that has literally zero infiltration happening. So barrier number 2 that we're going to talk about is an all or nothing mentality. So this means when you have a challenging site and you know that you're not going to be able to fully meet the green infrastructure requirements, the attitude is, well, I can't do anything. I'm not going to do any treatment. It's not possible. We're just going to do nothing. So this is a problem because, again, it's a requirement of our permit, right? We understand that there are challenging sites, but overcoming this barrier is really trying to change your mentality from all or nothing to all or something, right? Something. What can you do on your site? You know, could you treat only part of the site? You know, maybe the 20% area allowance isn't enough, but what portion of the site can you treat? Could you treat 30%? Could you treat 50%? What can you do? Or what if, is there a way to treat a lesser volume? So instead of, you know, a full ½ inch of rain, could you treat the first couple of tenths, right? Would that make things more feasible? Or as you're looking at different facilities, looking at different design options, could you modify some specific design criteria parameters? So changing, you know, the slope criteria or changing a maximum depth or something like that. Does that make things more feasible for your site? So the idea is to ask, what can you do? How can you encourage some portion of your runoff to contact vegetation or soil? That's your goal. Bring your runoff in contact with vegetation or soil. So, you know, whenever you encounter these situations, Watershed is very willing to work with people with projects on design variances. But when you come forward with those proposals, something is always going to be preferred over nothing, right? Removing some pollutants is better than removing none. So instead of thinking, you know, oh, my site's really challenging, I can't do this at all, try to think, okay, what can I do? Even though it's really challenging and I'm not going to be able to do everything, all or something. Barrier number 3 that we see a lot is limiting your toolbox. So we encounter people that commonly think that the facilities presented in the design criteria manual in chapter 2 are the only available or allowable options for green infrastructure. So overcoming that is first just recognizing that not only is that not true, it's actually addressed in the DCM that's not the case. So if you look at section 6.6 paragraph 1 of the DCM, it talks about that there are lots of additional stormwater controls beyond what's discussed in that manual, and that you're actually encouraged to explore those for sites where they might be appropriate, because there's lots of different tools. So the DCM was first rolled out at the beginning of 2018 for like a 1-year trial period before it became a fully implemented requirement. However, the tools that we put in the DCM were developed earlier, right? Around the 2013, 2014 timeframe, because it took several years to get the DCM through the public outreach and review processes and all of that. There was a whole lot of stakeholder engagement that happened for that, which a lot of you were a part of, and I'm sure a lot of you remember. But keep in mind, the entire United States has been doing green infrastructure, has been working on how to implement green infrastructure. So since 2013-14, there has been a lot of advancement in this field. So what I call the tools in the DCM, I call them the early basics. They're very relevant, they're very helpful, they're very foundational, but there are some other tools out there now that can often be really helpful that I would encourage people to look at, especially when you have a difficult site, because there are difficult sites all across the United States, and people have been trying to come up with ways to meet this green infrastructure requirement in a lot of different challenging sites. So, you know, when you're going to look at something that's a little bit different, that's not in the DCM, you may not find like a very standard, typical cross section that you can just pick up and plop into your site. You know, the cookie cutter is not necessarily going to work, but that doesn't mean that there can't be great options out there that will work really well in a variety of environments. So I'm going to show you a few tools that I think are either underutilized or could be modified to be very flexible. And then once again, guys, this is not all of them. I don't have time in the amount of time we have allotted to go through all of them, but this is a few to get you started. So one of them is the planter that I already showed you. So you already saw this slide. This is a stormwater planter. It can be used pretty much anywhere that you put landscaping, right? So parking lot or in a roadway application. Like we talked about before, it doesn't have to rely on infiltration, which makes it very flexible. You can put it in a whole host of locations. However, if for some reason you do have a site where you'd like to use infiltration, this can be configured with an open bottom. You don't have to actually put the concrete here. That's always an option. So this is one tool that I think has a lot, and again, it's just the bioretention cross section contained in a different way. Another tool that I think is very promising, has a lot of flexibility associated with it that a lot of people might not be familiar with, is called a Silva-Cell. So Silva-Cell is actually a proprietary product made by a company called Deep-Root. And I first became familiar with these in a project that we did up in Fairbanks. This is a picture of a Silva-Cell installed on Cushman Street in Fairbanks. So Silva-Cells were originally developed with the intent to be able to plant trees at a closer spacing in a very urban environment and have them not die, right? So they need room for their roots. So it was originally created for that purpose. It's basically just a high strength but low, like a lightweight grid system that you can put underneath concrete, just like it's shown in this photo. You can put it underneath asphalt. You can put it underneath pretty much any impervious surface, and it holds up. It provides that basically it is in place of putting in a structural section. It holds up structurally, not so much in driving surfaces, right? So the Silva-Cells are not usually put under drivable surfaces. They're more for walkways and plazas. But the one in Fairbanks, it's been in for several years. This picture is actually a couple of years old, and I think they're performing quite well. But it didn't take people long after starting to use them for tree growth to realize this is actually a great stormwater treatment tool as well, because you're essentially creating a bioretention environment underneath an impervious surface. So there's lots of different ways you can get water into a Silva-Cell. In the section that I'm showing here, it's a regular curb opening. You can put in subdrains so that percolation into the subgrade, actual infiltration doesn't happen if you don't want it to. These subdrains can be placed vertically, wherever works for your site. There's lots of different ways to configure them. I'm going to show you one other picture. These pictures are from Deep-Root's website. They actually have lots of videos, photos, design guides. There's lots of tools on Deep-Root's website if you're interested in this. But it's essentially just a grid system. In this case, it's the small size. They come in different sizes. That's going to go right underneath a sidewalk. So lots of options here. So I want to clarify really quickly. In this typical section, because of what it was developed for. It's showing it underneath permeable interlocking concrete pavers. It doesn't have to be. It can be under just straight concrete or asphalt, just any impervious surface. This is one way you can bring water into the subgrade, but you can just do it through a regular curb inlet as well. Also, this wouldn't necessarily have to be a tree. You could do any vegetation here, really, that you are interested in. Okay, so another tool that I think is pretty outstanding and pretty underutilized is just filter strips. So filter strips sound complicated, but literally all they are is a strip of grass. That's it, just grass. It's actually preferable to use grass for a filter strip as opposed to other vegetation, just because of the way a filter strip slows water down. The individual small blades of grass are actually much more helpful in this application than larger woody vegetation type things. So the top two pictures, this is the Taco Bell McDonald's complex in South Anchorage. And you can see they have quite a bit of green space. Their entire impervious surface, the whole parking lot, everything is being sent to landscaping or vegetation before it enters the storm drain. So in this picture, it's hard to see, but there is a curb cut right about here that flows over this hill, and water kind of spreads out as it comes down this slope and then is collected in this beehive inlet here before it goes to the storm drain. If you had a different application where you didn't need curb here, you could just send water directly down this side slope. There's your filter strip and there's your treatment. So pretty simple concept. This is a similar situation, this picture on the top right here. Again, water coming in through curb cuts that come down. This is not a design failure. This is an elevated inlet. This is done on purpose. They're actually getting some detention here as well as treatment. So filter strips locally, and then here these are both out-of-state examples. So this is just a little strip of grass that's treating water coming off of this pathway before it goes into this bioswale here. I showed this though because if you have a more rural like a roadway section where you have a separated pathway, or you have actual roads, different directions of traffic that are separated, this is sometimes a pretty easy and pretty helpful way to get your green infrastructure treatment, and it's just a grass slope. It's relatively simple. This one on the bottom right is interesting. I included this because when I first looked at this picture, I thought, obviously this is not Anchorage, right? This is not even the United States. I believe this is somewhere in Europe. But at first I thought this is not a filter strip, and I was confused. I finally realized stormwater is coming in through this curb cut here, and the filter mechanism is actually happening longitudinally down this narrow strip of grass. So the inlet to this is actually somewhere off the page, kind of down here. And I just thought that was a different way to do a filter strip. So water's coming in and, flowing along this grass and then getting collected downstream somewhere. Just a different application. But because filter strips are so flexible and relatively easy to design, I think they are a little bit underutilized and could be a great tool for certain applications. Okay, so that's the end of my tool list. There are so many more. If you're interested, please feel free to ask questions or reach out to me. We have lots of other tools, but those are the ones I wanted to show you today. We're going to move on to barrier number 4. To our barriers to implementation. And so barrier number 4 is believing stormwater myths. So I get told a lot of things about stormwater that are just simply not true. I think there's just a lot of things that come up that people are concerned about design failures. And so there's lots of stormwater management myths out there. So the way to overcome that really is, before you discount an idea or a concept, dig into it and find out if the myth is true. Like, find out if what you're hearing is actually true or if it can be overcome. A lot of green infrastructure related myths started with either a misconception or a poor design or a very poor construction that caused this facility to fail. But good design practices and quality construction can overcome a lot of those. So I'm going to share a couple of myths with you today. Again, not all of them, but a couple that hopefully you'll find helpful and potentially surprising, and maybe encourage you to reach out and dig into other myths as you encounter them. So the first myth, and I hear this a lot, is that green infrastructure facilities are just going to fill with sediment and fail in Anchorage. They don't work because, we put a lot of sand on the roads and there's lots of high sediment load and it's just simply not going to work. So that is indeed a myth. It's not true. The truth is you do need to have your green infrastructure facilities properly sized, and you need to consider your sediment inflow when you are properly sizing them. Related to that, you need an overflow for flood flows. So if your facility is not designed to handle flood flows, if it's just a treatment facility, you need to give it somewhere to go for flood anyway. And as it does accumulate sediment, you need it to be able to still bypass water safely downstream as that happens. And then if you have a facility that relies on infiltration, you need an in situ, like right at your facility, you need an infiltration field measured infiltration rate, not something, taken from a text or from a field lab or lab report. You need something actually measured in the field. Those things will help a lot. So related to that myth is also the myth that green infrastructure facilities are all very maintenance intensive. This is not true either. They can be maintenance intensive, but there's a lot of things you can do in design to help minimize maintenance. So I'm going to talk about a few of them as we go through the rest of this presentation, but the way you configure the facility in terms of access for maintenance, its size relative to the incoming sediment load, how much room you give sediment to build up so that, how often it would actually need to be cleaned out, where and how you situate your inlets. These are all things that can help minimize the level of effort for maintenance. And then, landscaping, which we're talking a lot about, combining stormwater with landscaping to achieve green infrastructure, it requires maintenance as well. So to the extent that you can couple those two things, you're going to minimize your maintenance a little bit too, because you're already usually maintaining your landscape. So I want to talk to you just briefly about this infiltration facility, because it is a myth buster for both of these two myths. This is DOT's infiltration pond that's located at the corner of the Seward Highway in Alpenhorn. This is just upstream of Campbell Creek. Campbell Creek is located just down here in this picture. So this little infiltration pond is taking stormwater from about 7 acres of impervious surface. And that's not 7 total acres, 7 acres of straight impervious surface from both the highway and surrounding areas, okay? And you can see in the photo, I don't have the dimensions here, but it's not terribly big, right? So just right off the bat, knowing that 7 acres are coming into an area this small and expecting infiltration, I was initially concerned. Like, that seems like a very high incoming sediment load for such a small location. On top of that, I visited this site during construction to try to come up with how we were gonna monitor it for performance. So we actually installed instrumentation and monitored the performance of this infiltration pond for a couple of years. So when I visited it during construction, I talked with the construction manager, and he told me that they were using this area during construction to capture all of their sediment coming off for their SWIP controls, for their construction stormwater, and that they were putting all the sediment here. And I cringed and I thought, oh, this is not good, right? Like, the facility's getting a huge incoming sediment load before it ever even has time to stabilize and actually perform the way it was intended. So I was very nervous. So when it was done and they told us it was ready to be monitored, ready for the instrumentation to go in, I asked the construction manager, did you remove that sediment before you brought it online? And he said, no, we did not. So I went into this expecting, because I believed some of these myths at the time, right? I went into this expecting this facility to be performing very poorly. And the truth is, this facility is fantastic. It is performing so well. It was designed to be able to take and infiltrate the first half inch from the contributing area, the first half inch of rainfall, and it's actually taking almost about the 10-year event before it ever overflows. When it does overflow, it's just a little earth and rock weird right here. Water just fills up and it flows down this ditch and goes right into Campbell Creek. So it's doing really great. It was constructed in 2013, I believe. We started monitoring it in 2014, so I think it was constructed in 2013. Started out with a huge sediment load, and to my knowledge, DOT has not had to come in and clean sediment out of this facility at all. I would think they maintain the vegetation, but I don't think it's required sediment removal yet. And it's been several years. So mythbuster right there. It's a great pond. So another myth that I hear a lot, curb cuts don't work because they're just going to fill with sand and block inflow. I hear that a lot of times from both designers and from maintenance people. So the truth is this can be true. It can happen. It's happening here in this photo. So this is a local school. I can't remember exactly which school this is. I didn't take this photo, so I'm not sure, but this is one of the local grade schools. And you can see that's what's happening here, right? So sediment has filled in actually enough that grass has actually kind of overtaken this curb cut. The same thing's happening down here. Water is supposed to be going over to this swale, and it really can't get there. So this can be a problem, but this is a problem that you can design for it, right? You can design to make sure that this doesn't happen. So one of the ways to do that, this is a really extreme example and obviously has its own issues, but you can give a vertical drop from where water comes into your facility to where the sediment is going to start to accumulate. Give it some room, give it some space, right? This one in this picture has a vertical drop of several feet, right, which is probably like a fall hazard for this sidewalk. But my point is it can be done, right? Very much so. Same thing for here. This is more of a swale concept like this one, but look at the fall between where water's going to come into this facility versus where sediment is really going to accumulate. It helps a lot to give some vertical distance there. The other thing you can do sometimes, maybe they couldn't make this any deeper. Maybe there's a utility line here or some other vertical constraint so that you couldn't drop. You couldn't actually give this vertical separation. In that case, what I would do is I would put in some kind of little concrete flume. The sediment will accumulate less if you can, put it on concrete, and also if they need to come and shovel the sediment out, it will be easier to do that if there's a little concrete pad. And then lastly, in a lot of situations, you can actually use an inlet style opening instead of a curb cut if you don't like a curb cut, if you're worried about this or you're worried about other maintenance issues with curb cuts. An inlet facility like this, or you don't necessarily need this space here. Just a regular inlet is often just as functional, just as acceptable as a curb cut, depending on the situation. Okay, so my next myth, and again, I hear this a lot, it's about permeable interlocking concrete pavers, or PICP. I want to give you a quick introduction to what PICP is so that you can understand the myth a little bit better. It's basically just concrete blocks with some type of pervious surface in between them. Usually, to be considered PICP, this surface in between is usually some kind of crushed aggregate. So sand or something porous. It's usually not vegetation. If it is vegetation, it's usually more of a geogrid application, but to be considered PICP, usually this is, yes, like I said, some kind of aggregate. And so water that falls on the surface, instead of just all of it running off, it's able to percolate down through into a subbase that can be designed based on the facility. There's lots of considerations that go into how to design this subbase. This is a picture locally of PICP. This was done at a housing development in the Spenard area. Tomasz Diak was the designer of this facility. And you can see water, it's raining in this picture. Water's not running off of, because it's sloped towards the storm drain inlet here, and you can see nothing's getting to the storm drain. So this is a local, as far as I know, this is the only real local example in a very urban environment. This is obviously an out-of-state picture, but still, this is PICP with there's smaller void space openings here. But it's most successful when used in these types of applications, plazas, walkways, things like that. It can be done in parking lots and drivable surfaces as well. It's usually not recommended for high-speed applications at all. But there's not a lot of it in Anchorage, and one of the reasons that I hear a lot as to why we can't use it in Anchorage is that it won't work because it's going to heave out of the ground during the freeze-thaw cycle, and that they can't be plowed. So you're going to catch a snow plow blade on them, and you're going to just, tear up the whole thing. So the truth is, that is only true if they're really poorly designed or poorly installed. It can definitely happen if they're poorly designed, poorly installed, but quality design and quality construction eliminates those issues entirely. So ASCE did a really great study of the performance of PICP in a couple of cold climates, specifically Chicago, Minneapolis, and Toronto. And they presented the results of the study. It's actually discussed in a design manual. ASCE put out permeable pavements design manual, a design guide. It's a great resource if you're considering utilizing any of those types of surfaces. But they talk about the cold weather performance of PICP, and the study showed that it actually does not heave when it's frozen. In terms of applicability to cold climates, PICP has a really great performance, according to what they found. Again, when it's properly designed and installed, and ASCE also talks about limitations in terms of what I just said, placing it on high volume roadways and things like that. But when used appropriately, it performs really well. So the other thing that we heard a lot is that you can't plow it, right? Because it's going to catch a plow blade, and even our sidewalks and plazas usually get plowed somehow in the winter because we get a lot of snow. So the truth is that's not the case. So as part of another project that we did, it was actually another project up in Fairbanks, we actually reached out to 7 different snowplow operators that regularly plow PICP. We found some PICP projects done by other cities, counties, states. We reached out to them and we played phone tag until we could get a hold of the people that actually maintain those facilities, because we wanted to talk to them to find out if they're plowing any differently, or what they're plowing with, if there's special equipment needed, things like that. And so unanimously from all 7 of them, we heard they don't plow it any differently than they plow the rest of their streets, and that they're using regular equipment. So specifically things like a Boss snowplow on an F-350 pickup truck, or a skid steer, or things like that, things that we see commonly used for plowing around here as well. So they did know, one of them specifically, we had a conversation with about the fact that maintenance issues come up when it's a poor construction. So he specifically told us, if you notice, you look at these examples, there's no edges of these of the actual pavers. They're not sticking up, right? Even though this is sloped, it's definitely sloped to this curb line. It's all in the same plane, right? You don't have jagged edges sticking up. So a poor construction would result in a jagged edges, and that's where snowplow operators catch them and pull them out. But he said when they're properly installed, they don't have any issues with snow removal at all. So that's just a myth that I had heard for a long time, and wanted to share with you because it is surprising to some. Okay, and then our last myth of the day, once again, is thinking I have to infiltrate stormwater. I know we've already talked about this a little bit, but we can't emphasize it too much. You don't have to infiltrate stormwater. You can actually filter it instead. So this is a picture, we saw a picture of this earlier on someone else's presentation in its early stages of construction. This is a more recent picture of the West Dowling bioswale. This is at West Dowling, not far from C Street. C Street's just here in this photo. So this is, again, it's accepting stormwater from a relatively high impervious area and quite a few acres. And it's performing treatment primarily through filtration through this vegetation, right? Water is coming into this facility from several different storm drains coming in from the sides. And then water is slowly flowing through this vegetation, mostly through filtration. There's a little bit of infiltration happening as well, but it's mostly filtration. And then there's an outlet that flows right to Campbell Creek, just out of the photo this direction. So you don't have to infiltrate stormwater. There's lots of good examples of filtration working just as well. Some final tips that I'll give you for implementation challenges as you're working through difficult sites. Probably the 2 biggest ones I could say would be use your site's landscaping. If you have landscaping of any form on your site or in your roadway or whatever the case may be, trying to let that double edge your green infrastructure treatment is going to be the easiest way that you could go. some type of landscaping, and again, remember the all or something mentality. If you have landscaping, try to use it. We did have some barriers initially about that not being allowed in municipal code. Christy actually mentioned that earlier as well. It is specifically allowed in municipal code now, so keep that in mind. You don't have a code compliance issue if you're doing that. Another thing, and you've probably heard me say this before, you have to start early. You can't come in at a 65% or 95% design and say, oh, I need to add stormwater treatment. It has to be done with your grading plan. So when you're setting line and grade, when you're deciding where water is going to flow and how it's going to break and all of that, that's at the same time that you need to be deciding how you're going to incorporate green infrastructure, because it's very difficult to use your landscaping for stormwater treatment if you haven't designed your site to drain somehow, either via a pipe or via overland flow to the landscaping, right? So keep that in mind. If you try to do it as an afterthought, it's going to be a whole lot harder. It needs to be done early. I think one of the challenges, one of the reasons that I see people trying to do it as an afterthought is I think sometimes you have a different person that's doing maybe your site design or your grading plan versus the stormwater treatment, also versus the landscape design, right? So those are often different people on the same design team. And you just have to recognize that collaboration across those different people is going to be needed to make this successful, right? And if you recognize that early, I think it's very achievable. I think we can collaborate and come up with some pretty great options. And then lastly, get creative, right? Look for some options that can work with your site that may or may not be incorporated in the DCM. Think about how you can mix and match. There are, like I said before, lots of different resources out there for difficult sites and for different green infrastructure configurations. And if you still can't find one, or you still need to make some modifications, then consider doing design variances where it makes sense to do so. Instead of nothing, all or something is a better way to look at it. So I want to show you a couple of resources that I think are helpful. This is the Green Streets Plan that we did actually for fast planning. It used to be FMATs. There's some helpful resources in here that I think this group might find useful. And then the Minnesota Stormwater website, as well as the EPA's Green Infrastructure Design and Implementation website, both have a lot of tools for designers. I like this one the most, and I'm actually going to show it to you. I mean, they're both helpful, but I'm actually going to show you the Minnesota Stormwater website quickly. So this is just a really helpful resource. Again, it's not all inclusive. You won't find every type of tool available here, but there's lots of introduction into stormwater management and stormwater information. But the thing that I like the most is you can actually look at different stormwater control practices, either by type or by treatment mechanism, right? So the treatment mechanism piece is I think is helpful. So if you know that infiltration is not going to be possible on your site for any of the reasons that I mentioned before, maybe you want to click on filtration practices and actually look and see what other filtration options are there. And so here they are, different filtration options that is presented on this particular website, and they have helpful graphics for the different ones. If you click on them, you can see that. So these are just a few resources that I find helpful if you're looking for ideas or looking for additional criteria, guidance that you might be able to check out. So that is actually the end of what I have prepared, and I'm open for questions or conversation. Do we have any questions, guys?